In Episode 10, titled 1.2 Select Data Sources, Databases, APIs, Web Scraping, Files, and Logs, the focus is treating sourcing choices as deliberate trade-offs rather than as automatic defaults. The CompTIA Data Plus DA0-002 exam often describes a business question and then tests whether the chosen source fits the need for freshness, accuracy, permissions, and reliability. In real work, the best source is rarely whatever is easiest to grab, because ease today can create risk tomorrow when someone asks where the numbers came from or why they changed. A disciplined approach starts by recognizing that every source type has strengths and weaknesses, and the right choice depends on the decision being supported and the constraints implied in the scenario. Source selection is also a governance act, because pulling the wrong data or pulling it the wrong way can violate policy, even if the analysis is technically correct. The aim in this episode is to build a stable mental model so that when a STEM lists possible sources, the best one feels like a reasoned fit. A strong sourcing decision begins with the question, because the question defines what good data means in that moment. Some questions demand precision and traceability, such as financial reporting or compliance summaries, while other questions demand speed and direction, such as operational monitoring or incident triage. Some questions demand current state, such as current inventory, while others demand history, such as month-over-month behavior. The question also implies granularity, such as whether an answer needs event-level detail or aggregated totals, and it implies who will use the answer and how sensitive the data might be. When the question is clear, the source can be chosen based on whether it contains the right fields, whether those fields are defined consistently, and whether the data can be obtained within access constraints. The exam often rewards this mindset by presenting answer choices that are technically possible but mismatched to the question's intent. Databases are often the best source when the need is governed, queryable, structured records that are maintained as a system of record. A database typically enforces schema, supports filtering and joins, and provides consistent access patterns that are easier to audit than ad hoc exports. This is especially useful when the scenario emphasizes consistency, completeness, and repeatability, because a database can provide a stable definition of tables and fields. Databases also support controlled access methods and can separate read workloads from write workloads, which matters when performance and integrity are important. On the exam, a STEM that mentions authoritative records, stable schema, or reliable reporting usually signals a database source as the intended choice. The trade-off is that databases may not always provide the freshest derived metrics if those metrics are calculated elsewhere, so the question still drives the final decision. API sources are often the best fit when controlled access and fresh updates are the priority, especially when the data is owned by an application or service that is designed to share it safely. An API typically exposes specific fields through defined endpoints, which provides a clear contract about what the data means and how it can be requested. That contract can be valuable when governance matters, because it restricts access to what is intended to be shared and can enforce authentication and authorization. API access is also often the most current view of operational data because it reflects what the service knows now rather than what was exported last week. The trade-offs include rate limits, pagination, and potential partial returns, which can create subtle gaps if the collection process is not designed carefully. Exam scenarios often use language about latest updates, controlled access, or integration, which points toward API sourcing as a strong option. Web scraping is a distinct category because it can be technically possible but operationally fragile and ethically sensitive. Scraping often depends on the structure of a web page, and page structure can change without notice, breaking extraction logic and producing wrong data silently. Scraping can also raise legal and policy concerns because the page content may have terms of use and the data may not be intended for automated collection at scale. Even when permitted, scraping introduces uncertainty about field definitions because a displayed number may be formatted, rounded, or updated in ways that are not documented. On the exam, scraping is often presented as an option that seems convenient, and the intended skill is recognizing the risk and choosing a more governed source when available. When a STEM emphasizes reliability, compliance, or long-term repeatability, scraping is usually a weaker choice unless no other path exists and the scenario explicitly supports it. Files are a common source because they are portable and easy to share, and many organizations move data through exports in formats like CSV, XLSX, or JSON. Files can be appropriate when the scenario involves a snapshot, a handoff between teams, or an offline analysis that does not require constant refresh. The primary risk with files is version confusion, because multiple copies can exist with similar names, and small differences in export timing or filtering can produce inconsistent results. Files also often lack strong field contracts because a column may be renamed, reordered, or formatted differently across exports without a clear schema enforcement mechanism. Exam stems sometimes mention an exported file, a spreadsheet from a vendor, or a shared report, and those cues should trigger awareness of snapshot behavior and version control concerns. Files are useful, but they require careful labeling and lineage tracking to keep results trustworthy. Logs are a special source because they provide behavior trails, timestamps, and contextual clues that often do not exist in clean business tables. Logs capture events, such as authentication attempts, service calls, errors, and user actions, which makes them valuable for operational insight and for understanding sequences over time. In cybersecurity adjacent scenarios, logs often contain the evidence needed to explain what happened and when, which supports incident analysis and monitoring. The trade-offs are that logs can be noisy, inconsistent in structure, and heavy in volume, and time zone assumptions can distort timelines if not handled carefully. Logs also often contain sensitive information, so access controls and retention rules are central to whether they can be used and how they must be protected. On the exam, language about event trails, timestamps, or behavioral context often points toward logs as the most relevant source. Comparing sources across latency, cost, reliability, and access constraints keeps selection grounded in practical trade-offs. Latency describes how current the data must be, because some decisions tolerate yesterday's snapshot, while others require near real-time updates. Cost includes both direct cost, like platform charges, and indirect cost, like engineering effort and maintenance burden, which can be high for scraping or complex API collection. Reliability includes both availability and consistency of definitions, because a reliable source is one that is not only up, but also stable in what fields mean. Access constraints include authentication, authorization, and privacy boundaries, because a technically useful source is still unusable if the analyst cannot legally and ethically access it. Exam stems often include at least one of these constraints implicitly, and the correct answer usually matches the most important constraint. Permissions and data ownership should be checked before pulling anything, because access is a policy decision as much as a technical one. Data ownership determines who is allowed to share the data, what approvals are needed, and what constraints apply to storage, retention, and onward sharing. Even within the same organization, different systems have different stewards, and pulling data without authorization can violate governance, privacy, or contractual obligations. The exam often tests this indirectly by describing sensitive data, third-party platforms, or regulated information, where the correct response emphasizes proper access and compliance rather than speed. A professional approach treats permissions as part of data quality, because unauthorized data can never produce a trustworthy deliverable. When in doubt, the safest interpretation is to choose sources and methods that are explicitly approved and traceable. Fields should be validated across sources and systems because the same label can mean different things depending on context. A field called status might represent shipping status in one system and account status in another, and a field called date might represent event time in one place and processing time in another. Differences in rounding, currency, time zone, or aggregation can create mismatched totals that look like analysis errors but are really definition mismatches. Validation begins by comparing field definitions and then comparing small samples to confirm that values behave as expected. Exam scenarios sometimes describe conflicting results from different sources, and the intended skill is to reconcile meaning before reconciling numbers. A candidate who checks definitions first tends to choose answers that produce explainable results. Operational realities like rate limits, outages, and partial returns are especially important when sourcing involves API collection or distributed systems. Rate limits can restrict how quickly data can be pulled, which can force batching and pagination, and careless handling can miss records without obvious errors. Outages can create missing windows, and partial returns can create silent incompleteness if the retrieval process does not detect and recover from gaps. Even databases can have maintenance windows or replication lag, which can make current data less current than expected. Exam stems may mention intermittent failures, time pressure, or incomplete results, and those cues should trigger awareness that collection plans must anticipate and handle these realities. The goal is not to build complex solutions, but to recognize that a source choice is incomplete without a plan for its failure modes. Lineage details should be captured, so findings remain trustworthy later, especially when results will be questioned or reused. Lineage includes what source was used, when it was pulled, what filters were applied, what fields were selected, and what transformations occurred before analysis. Without lineage, a result can be correct in the moment but impossible to reproduce, which undermines trust and makes future comparisons unreliable. This is also where governance and auditability connect to everyday data work, because many organizations require traceability for decisions that affect customers, finances, or compliance. Exam questions may hint at traceability needs by mentioning audits, stakeholders, or repeated reporting cycles, where lineage is the difference between a credible report and a fragile one. A professional mindset treats lineage as part of the deliverable, not as optional commentary. A decision tree for common scenarios can be held as a mental flow rather than a written checklist, because the exam environment rewards quick, structured thinking. If the question demands authoritative, stable, structured records with consistent definitions, a database source usually fits best. If the question demands fresh updates with controlled access and a defined contract, an API source often fits well, with attention to limits and completeness. If the question involves behavioral trails and timelines, logs often provide the necessary evidence, with extra care for time zones and sensitivity. If the scenario is a one-time snapshot or a team handoff, files can be appropriate, but only when version and definition risk is managed. If a stem suggests scraping as a shortcut, the safer reasoning is to consider fragility, permissions, and ethics before treating it as acceptable. To conclude, Selecting data sources is a set of trade-offs shaped by the question, not a default preference for the most convenient option. Databases provide governed, structured records. APIs provide controlled and often fresh access. Web scraping can be fragile and sensitive. Files provide portability but can create version confusion. And logs provide behavioral context with heavy volume and time considerations. Latency, cost, reliability, and access constraints guide the best choice, and permissions and ownership checks keep the work compliant and defensible. Field validation prevents mismatch definitions from turning into misleading analysis, and planning for rate limits, outages, and partial returns protects completeness. One useful practice choice is to pick one recent analysis question and justify aloud why one source type is the best fit, naming the key constraint that drove the decision, because that habit mirrors the exact judgment the exam is designed to evaluate. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.